Okay, we're going to start our second type of transformation today, and this is called a translation. Again, this is one of our rigid motion techniques. So the original image, which is called our pre-image, and our image, the final result, are going to be carbon copies of each other. They're going to be congruent. They're going to be identical. Okay, so a translation, or sometimes we call it a slide, is a function or it's a mapping of each point to its image along what we call a vector, and it's called a translation vector. It's kind of, sometimes we just say it's a rule, and the way that we get the problems on Alex are pretty direct, pretty straightforward. Okay, let's talk about this. So the figure below is marked with a large dot, so they put a dot on the corner. We're going to translate the figure 8 units to the left and then give the coordinates to the marked point in the original figure. All right, to translate it 8 units to the left, I'm essentially going to look at each of the four corners and we're just moving them directly to the left 8 units. So we're at 6, 7, 8. This point will be here. Start at this point, 8 will be right on the origin. Start at this point, go 8 will be over here. Take this point and go over 8 units will be here. So if I translate it over 8, it's going to look like this. So basically, we take the four corners and we all slide them 8 to the left. Okay. So that's what a slide is. You move it the direction they tell you to move it. And usually you're going to get a left, right, up, down movement. So you got to do a combination. Okay. But what you need to notice is the points, each point has moved the same distance and in the same direction. Each point moves the same distance and in the same direction. So the question here said, what's this point going to be in the final figure? So our original point is here at 6, 3. When we go 8 to the left, it's at -2, 3. Okay, and I'm going to show you more about that here in a second. But this is what it means to translate or to slide. All right, the figure below has a marked with a large dot point here. First, translate the figure 6 units to the left, and then 5 units up. Now, see this in here, this symbol that surrounds this. This is typically how they give it. This means a vector. All right, and I put -6, 5. Now, the reason it's -6, it's just like an XY ordered pair. Think of it that way. So for the x coordinates, I'm going to go 6 to the left. Moving to the left on the x-axis is negative. For the y coordinates, which are up and down, I put 5 because we're going to go up 5. So the sign on this is telling you left or right, up or down. All right. The first is for what we do to the x. The second is what we do to the y. So I take this point, we're going to go 6 to the left and we're going to go up 5. And we're really going to do it for all four corners. And if I do it, go 6 to the left, up 5, and do it for all of them. 6 to the left, up 5, 6 to the left, up 5, 6 to the left, up 5. The image gets moved to here. It's like sliding it from here to here. Okay. It wants the coordinates of the original figure and the final. So the original point here was at 2, -4. When I slide it left 6 and up 5, it goes to the point -4, 1. Now, my point here for showing you this is if you take 2 and subtract 6, you get -4. If you take the y coordinate -4 and add 5, which is our change here, you get +1. So that's why they'll give us vectors. Now, they don't do it on Alex, but you'll see this describe this way of telling you how to move a shape. Okay. So talking about properties here, this says translate the figure up 5 units. So that means we're not moving it in the to the left or to the right at all. So I put a 0 for x, and then we're going to go up 5, so that's +5 for the y. And then decide if each statement about translated figures is true or false. So if I do the translation, move every point up 5, up 5, up 5, up 5, it's going to slide to this position. Okay, now answer the questions. The final angle measures are larger than the original angle measures. No, right? They're identical to each other. This angle and this angle do not change. If two sides of the are parallel in the original figure, then those sides are parallel in the final figure. Yeah, they're the same. The final lengths are the same as the original lengths. The final side lengths are the same. Yeah, they're the same. The original figure and final figure are congruent. Yes, they are identical to each other. It's a rigid transformation. Okay. We've had this one similar in the when we did the reflections here. So it's basically saying, is it possible to take the blue shape, I think it's blue, and slide it onto the dash figure? If so, do it. If it's not, let them know. So in the first case, if I take the blue one now, so take this point. Go 1, 2, 3, 4, 5, 6 to the right. 1, 2, 3, 4, 5 down. Okay, take this point. Go 1, 2, 3, 4, 5, 6 to the right. 1, 2, 3, 4, 5 down. So it looks like it happens, right? If I go to the right 6 and down 5, I'm going to move every point the same. So can this one be done? Yeah, we can map it right on top. How about this one? Okay, well, if you look at it, if I take this corner point and go left and up, it should be right located right here, and that's not anywhere near the dash, right? So this shape is not going to be able to be translated using the slide figure, using slide or translations, or excuse me, yeah, translate. So we would say this one is not possible. Okay. All right. Next question, draw the following triangle after a translation of 1 unit left and 3 units down. So 1 unit left would be -1 for the x coordinates. 3 units down would be -3 to all the y coordinates. Now, on a grid, you don't really need to do that, right? So what we would do is, take every x coordinate, or excuse me, every vertice and go left 1, down 3, left 1, down 3, left 1, down 3, and then draw our triangle again, and there it is. There's our triangle slid left 1, down 3. Pretty straightforward. Okay, in the coordinate plane, x is located 0, 1, and then it's translated x prime to 5, -4. Under the same translation, the points y, which is here, and z, which is here, are translated to their new locations. What are the coordinates of their new locations? So basically, they're saying, let's take a look at what we did for x. X was at 0, 1, and we moved it to 5, -4. So we moved it 1, 2, 3, 4 to the right, 1, 2, 3, 4 down. So I went 4 right, 4 down. If I add 4, no, add 4, subtract 4, pardon me. Add 4, subtract 4. 1, 2, 3, 4. Yeah, I should be there. All right. So that's the rule. To the right 4, down 4. So take these points, z to the right 4, down 4, y to the right 4, down 4, and what are their locations? Well, z is now at 3, -6, 3, -6, and y prime, excuse me, is now at 1, -8. So I use x to find the rule, and then I apply rule to y and z to get their new coordinates. Okay. All right. The final question here is just understanding the rules and what has happened here. So what they've done in this question is taken triangle XYZ and translated it over here to get x prime, y prime, z prime. Okay. Now the translation is 8 units to the right and 3 units up. So that would be 8, 3. The first question says find the length of each of these distances and give exact answers, no decimals. So what's the distance from x to x prime? Well, when we find distance in the coordinate plane, we got to use distance formula. So x is at -7, -1. X prime is at 1, 2. So use the distance formula. It's the square root of the difference of the x's squared and the difference of the y squared. Square root, and this is group now. You got to remember that. So -8 squared plus -3 squared. That's going to be 64 plus 9. And it said give exact answers. So I'm going to say it's the square root of 73. All right. What's the distance from y to y prime? Y to y prime. Well, y is at, oh, shoot. Yeah, I did z. Z. Yep. I'm sorry. I'm doing z right now. All right. So I'm doing z to z prime. So z is at -8, -7. Z prime is at 0, -4. How far is it? Well, distance formula. -8 minus 0, difference in the x squared. -7 minus -4, difference in the y squared. Okay. I wind up with -8 squared plus -3 squared again. And the answer is square root of 73. That should have been here. All right. What's the distance from y to y prime? Well, y is at -2, -2. Y prime is at 6, 1. The distance is the difference in the x squared plus the difference in the y squared. Lo and behold, I get -8 squared plus -3 squared. So what this shows you is when you do a translation, each point is moved the exact same distance. X to x prime is the same distance as y to y prime is the same distance as z to z prime. That's the point. Okay. We're moving, even though we're going, a direction up and down and left and right, they're still moved the same distance. Okay. Second question. What's the slope of these lines? Well, what's the slope of x to x prime? Now we could just count, right? Well, I did it fancy here. So I took x and x prime, the difference in the y's over the difference in the x's gave me 3 over 8. Okay, z to z prime. Okay, I took the coordinates, I did the difference in the y's over the difference in the x's, and I got 3 over 8 again. And then the difference in the y's, I keep putting those in the wrong spots. Difference in the y's over difference of x's, and lo and behold, I get, that should be a 2, sorry, 3 over 8 again. So what's the point here? The point is they're all traveling on the same path. All right, they're going the same distance, and they're doing it parallel to each other. This line, and this line are all parallel. Okay, it's the same rise and the same run for each of them. So the first two questions here are showing you they're going the same distance, and they're doing it on the same angle, if you will. They're traveling on the same path. Last question, choose all the correct statements here. All the points on the original figure move the same distance, but not all the points move the same direction. False. They all move the same direction. All points on the original figure move the same direction, but not all points move the same distance. False. We proved that in the first step. All points in the original figure move the same distance and in the same direction. Correct. All points in the original figure didn't move all the same. No, that's wrong. Okay. So that's translating. Okay. And it's pretty straightforward to work on. Alex makes it nice to do. And I will let you have at it.